Okay, I'm going to talk to you about some new functions. We've done cosine and sine. Let's do secant, cosecant, and tangent. Okay? Let's do cosecant of x. Remember, co does not go with cosine. Cosecant is 1 over sine of x. Okay, here's pi halves pi, so every dash here is pi halves. Here's 1 and negative 1. Okay, so I'll graph a sine curve. Remember, it's 0 here. Where's sine 0? On the unit circle. It's always 0 at the 0 pi intervals of 0, 2 pi, 4 pi, 1 pi, 3 pi, and so on. Okay? So 0, and it's always 1 and negative 1 at pi halves and 3 pi halves at intervals of pi from there. Okay? So 1, 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, and so on. If I go this way on the unit circle, I go negative 1, 0, 1, and so on. Okay? Now, let's talk about 1 over sine of x. I've got a denominator. I can't have, first of all, remember, in a normal sine curve, my domain is all real numbers. Okay? And my range normally is between 1 and negative 1. Okay? Unless we change it up. Okay? And this keeps going. All right. So now I've got a denominator and 1 over sine. I can't have 0 in the denominator. It's an undefined function. 0 is never in the denominator. So let's block off what we can't have. So I'm 0 here, here, here. All these intervals of pi. Okay? So my domain, x cannot be, and I'm going to say k is any integer. What's an integer? Negative 2, negative 1. Not a decimal. 0, 1, 2, 3, 4. So any k times intervals of pi. So 0 pi, 1 pi, 2 pi, 3 pi, negative 1 pi, and so on. Other than that, we're good. Okay? So remember, 1 over any time, the smaller the denominator, the huger number you're going to get. 1 divided by a tiny number is a very big number. 1 divided by a bigger number, the bigger your denominator, the smaller your dividend, the smaller, the bigger your dividend. So the biggest we're going to get is 1. So 1 divided by 1 is 1. Here's where it's 1, right? Okay? Well, first, and let me backtrack. Okay, so all these places where sine is 0, I'm going to block off with asymptotes. Those are my roadblocks. All right? Okay? And here's just a few. Got one here on the y-axis. Okay, any interval of pi. Okay? I can't have a graph there because I don't have anything to plug in there. Remember, for me to have a point on this line, I have to be able to put in something at 2 pi. But I can't, I'm not allowed to put that in my input because it's not in my domain. The domain is a list of all my inputs. A range, a list of all my outputs. Okay? So notice, the smallest value I'm going to get is at the biggest value of my denominator. Well, here's where sine is 1, so that's as small as this graph gets. From 0 to pi, all positive sine values. So notice, as I start getting, as we have very small values right here, sine, right? Here's this point. These are very small y values. Okay, near 0, 0.1 degree is a very minuscule sine value, so I have a very tiny, so 1 over a tiny number approaches infinity. But we never plug in 0, but notice the smaller these numbers get, remember 0.86, 0.7, 0.5, and so on, the smaller they get, the bigger these values get, and it approaches infinity. Okay? Now as far as being, obviously the greater up this way, the bigger the number, and the smaller this way, the smaller the number. But let's talk about big negative numbers, okay? So I hope you understand what I'm saying here, kind of like the absolute value of these numbers. All right? When I get on this part, from pi to 2 pi, yes, Robert?
You out today?
Afternoon.
Oh, okay.
Okay. I'm filming right now.
Oh, okay.
Robert interrupted Jander. From pi, from here it's negative values, okay? All right, but these are very tiny negative numbers, right? The smaller these are right here, notice this is a very tiny negative number, so 1 over tiny negative is a huge negative number. So it's going to be approaching, as we get over this way, the smaller I get, this graph approaches, so let me start here at 1. 1 over negative 1 is negative 1. And as this gets smaller negative, this gets bigger negative as a point, okay? And as I get smaller over here, this starts getting bigger or more negative. Tiny, tiny, tiny negative, very big, big, big negative number. So this is my denominator. Okay? So that's how you graph cosecant. Alright? Domain, everything but intervals. We eliminate every interval of pi. K, pi, where k is an integer. Okay, 0, pi, 2 pi. Okay? Range, 1 to infinity and negative 1 to negative infinity. Okay? 1, let's do this interval notation, parentheses. Always parentheses for infinity, negative infinity to negative 1 with the bracket, because that's included, union, bracket, 1, comma, and positive infinity. Okay? Alright. Cosecant, I want you to start thinking about all this yourself now. Okay? Secant of x equals 1 over cosine of x. Okay? As I graph my cosine curve, remember we're like this now. Starts off at 1, 0, negative 1. Remember, it's 1 and negative 1. Here, cosine's 1 and negative 1 at the pi's. 0, 2 pi, not the pi halves. Okay? Where's cosine 0? That's where you're going to have your asymptotes. Okay, now it's 0 at the pi halves. Okay? And the same basic principles. Okay? But it's going to be positive from where? From 0 here. And then it's negative from pi halves all the way to 3 pi halves, and then it starts getting positive again. Okay? And from here to here, notice from pi halves to negative pi halves, right here, this quadrant, these two quadrants here, cosine is positive. Okay? So notice, again, at pi halves, we have very small, tiny numbers for my x as I get very close here. Y is very big. But 1 over a tiny number, right here by pi halves, is a very big number. As this starts getting smaller, this starts getting bigger. Okay? Right at 0, cosine is 1. So 1 over 1 is 1. And notice as we start going 2 pi halves, cosine starts getting smaller. This starts approaching infinity and approaching that force field of the asymptote. And starts doing the same as this starts getting smaller. We've got the negative graphs, okay? Again, on your worksheet you've got tables to fill out for cosine of x, sine of x, and then what the cosecant and secant things would be, okay? Again, domain range. Okay, here, I can't have intervals of pi halves. But it's not any integer anymore. It's k pi halves. It's k pi halves, and k is not any integer anymore because I can't have. If I just put 1, 2, 3, 4, 2 is 2 over 2, and that's pi. Okay, and I can have pi, so it's got to be every odd integer, right? These pi halves are intervals of 1, 3, 5, 7, 9. Okay, so x cannot be any k times pi halves where k is an odd integer. Negative 1, negative 3. Okay, so here's negative 1 pi halves, negative 3 pi halves. Because we're dealing with pi halves now. Before it was pi. Okay, so think about how that worked out. Okay, sine, cosine. Think about, tangent is sine of x over cosine of x. I can have 0 up here. It's okay. So where's sine 0? Sine is 0 where? On the unit circle, here and here. Okay, that's okay. I can't have pi half at the pi half, so I'm going to have, just like secant, I'm going to have asymptotes, okay, at pi halves intervals where cosine is 0, okay? But this graph, notice, as I start getting from, let's talk about pi halves, let's say from pi halves over to, from pi halves to pi. Notice cosine is negative and sine is positive, so we have negative values, okay? Right here at pi, I've got a value of 0, okay? So from 90 degrees, when I'm at 90 degrees, just past 90, 90.1 degrees or 91 degrees, I have a very tiny negative x. Tiny, tiny negative x, and almost 1 is x. But 1 divided by a tiny negative is a huge negative number. Okay, so it's near, this is where it approaches, the closer I get, the closer I am to 90 degrees, the tinier my x value is, which gives me a tiny denominator, huge negative number. And as I start moving around, x starts getting bigger, so this starts getting smaller and smaller and smaller. At this 45-degree interval, remember, sine and cosine are the same, so it should be negative 1 right there, okay? And then it starts approaching 0. And then the same thing again as this comes around here. Now I've got negative, sine and cosine are both negative here, okay? So now negative over a negative is a positive, and we start getting down here at the 45-degree reference angle 1, and it starts approaching, as we get down to here, I start getting cosine very, very tiny, and it starts getting like so. So here's what a tangent function looks like. Understand the period, domain, range, same thing. I can't have any intervals that pi has. My range is no longer broken up. It's negative infinity to positive infinity. All right, this ought to have a great start for your assignment. I want quality answers on this stuff, okay? When I give you these springboard stuff, a lot of you guys just pencil whip some really bogus answers. I want you to think about what they're asking and answer appropriately. I broke it down, so there's not a lot. I expect some good work when I pick up the work Monday, okay? Have a good weekend.